Example 1. In spring 2013, Professor Li Zuofeng from University of Florida Proton Therapy Institute provided a talk about principles of proton therapy. Proton therapy is a relatively new tool for cancer treatment. Protons are accelerated in a particle accelerator to reach certain speed and directed to the tumor cells to kill them. Since protons carry positive charges, they can be accelerated by electric field. The mass of a proton is about 1.674 times 10 to the negative 27 kilogram. If a proton is accelerated to the velocity of 8.52 times 10 to the 6 meter per second, what is the wavelength of the proton using the de Broglie relationship? Well, the first step is always to summarize the most important information. The most important information includes numbers with units, what we are looking for, and balanced chemical equations if there are chemical reactions in the problem. Now let's conduct some analysis. Because this problem mentioned de Broglie relationship. Now let's look at what de Broglie relationship is. This equation is called de Broglie relationship. It shows the particle-wave duality of radiant energy. It says any particle or any matter that has a velocity will show a wavelength. We used to think the property of a particle and the property of a wave cannot belong to one matter. However, with this relationship, we can see that any matter can have both the particle property and the wave property. That's why we call this duality. Duality means each matter can have two properties. Lambda is the wavelength. The unit of the wavelength is meter. H is Planck's constant. It is equal to 6.626 times 10 to the negative 34 joule times second. M is the mass of a particle. The unit of the mass must be kilogram. V is the velocity of the particle. The unit of the velocity must be meter over second. If you are given different units for the wavelength, the mass, and velocity, please convert them to meter, kilogram, meter over second before you use this equation. Now let's go back to the original problem. Since we want to use the de Broglie relationship, let's write down the equation first. Well, from the summary, we know both the mass and the velocity of the proton. Since we know h is Planck's constant, therefore, to calculate the wavelength, it will be a single-step calculation. Now let me show you the work. Let me show you the mass. In general, we want to separate the numbers from the exponential terms. Well, in addition to separate the numbers from the exponential terms, we also want to separate the units. But as long as you use the right unit for each quantity, then the unit for wavelength should be meter. Since you may have a problem for this part, now let me show you more details. You can type in these numbers into a calculator to get the answer. Well, at the end, we have to convert the number into scientific notation. We are done. Can you follow my example to answer these two problems by yourself?